Ever wondered what happens when nerve fibers are cut across? These intricate threads form a vital part of our nervous system, functioning as highways for information transmission. Imagine severing one of these highways. There's a fascinating process that unfolds, known as Wallerian degeneration. It's not just a simple breakdown, it's a complex dance of degeneration and regeneration. The axons fragment, fatty substances form, and then the nuclei proliferate. But that's only scratching the surface. Now let's delve deeper into this fascinating process called Wallerian degeneration. Wallerian degeneration, named after the British neurologist Augustus Waller, is a process that begins when a nerve fiber is cut or crushed. This fascinating phenomenon unfolds in two distinct stages. Initially, the central ends of the fibers start to degenerate, but only up to the first node of Ranvier. Imagine the fibers as a line of dominoes, falling one by one, but stopping abruptly, leaving the remaining pieces untouched. Simultaneously, the peripheral ends experience a different fate. They degenerate throughout their entire length, not just a portion. Picture a rope fraying from both ends, unraveling completely, no matter how long it is. In this process, the axons crumble into fragments, their structure collapsing, much like a sandcastle succumbing to the relentless waves of the sea. It's a process that's as ruthless as it is fascinating, as it leaves nothing behind but the remnants of what once was a vital part of our body's communication system. But what happens to these degenerated axons? As the nerve fibers degenerate, the axons break up into fragments. This is not a random act of destruction, but a meticulously orchestrated process. The axons, once a vital part of the nerve fiber, are now surrounded by droplets of fatty substance, a direct result of the breakdown of the medullary sheath. Think of the medullary sheath as a protective blanket around the axon. When it breaks down, it releases these fatty droplets, almost as if it's crying out for the broken axon. This fatty substance isn't just debris, it's an important part of the degeneration process. Meanwhile, the nuclei of the primitive sheath aren't just sitting idly by. They're working overtime, proliferating, multiplying at an astonishing rate. This is not a futile exercise, but a critical part of the process. The nuclei are the unsung heroes here, playing a key role in the absorption of the broken axons and the fatty substance. But what happens to these fragments of axons and droplets of fatty substance? They don't just disappear into thin air. The nuclei of the primitive sheath absorb them, like a sponge soaking up water. This is a cleanup operation of sorts, ensuring that nothing goes to waste. But surely, this isn't the end for these nerve fibers. No, it's not. This is just the beginning of a remarkable journey of regeneration and recovery. The story of the axons is far from over. Indeed, it isn't. When the cut ends of the nerve are sutured together, regeneration of the nerve fibers takes place. Now, this isn't a simple process of just sticking things back together. Oh no, this is a sophisticated dance of biology, a testament to the resilience of life itself. Let's delve a little deeper. You see, this regeneration is led by the downgrowth of axons from the central end of the nerve. Imagine this like a tree sprouting new branches reaching out into the space around it. This growth isn't random or chaotic. It's guided, purposeful. At one point in our scientific journey, it was believed that this regeneration was peripheral in origin. Picture the branches growing from the outermost parts of the tree, rather than from the central trunk. However, this has been proven incorrect. So, where does the peripheral end fit into this? Well, it's not entirely out of the picture. The nuclei in these peripheral portions proliferate, multiply, and expand. They form what we can think of as a scaffolding, a framework along which the new axons can pass. Like a blueprint guiding a builder, this scaffolding paves the way for the new axons to find their path and restore the nerve's function. And so, the cycle of life continues, even at the microscopic level of nerve fibers. Fascinating, isn't it? The resilience and adaptability of life, from the grandest of organisms to the tiniest of cells. Wallerian degeneration is a testament to the resilience and regenerative capabilities of our nervous system. This fascinating process begins with the degeneration of nerve fibers, simultaneously occurring throughout their entire length. The axons fragment, their protective sheaths break down, forming fatty substances. The primitive sheath's nuclei proliferate, setting the stage for axon and fatty substance absorption. But here's the triumph. With the nerve ends sutured, regeneration ensues, guided by the central nerve end. So, the next time you ponder about the wonders of the human body, remember the incredible saga of Wallerian degeneration.